Okay, so we've looked at voltage drop and current flow. As far as the voltage drop, it positively identified the problem was here in my connector. Looking at available voltage on both sides gave me the same answer. I had a very large voltage drop across that connector. So again, two good things. Now, here's something that some people run into trouble with. That's with open circuit voltage. Let's just say that my light bulb, dim as it is here, I want to measure the voltage, and you'll see some people do this. Even if the let's just say the light bulb's not working, period. Sometimes you'll see people just simply do this. Pull the light bulb out. They're going to flip this thing over, and they're going to get in and they're going to measure the voltage available. Now look at this, I've got over 12 volts, okay? I have over 12 volts, yet when the circuit was operating, I only had 4 volts here. So again, this is something not to get confused over. Open circuit voltage does not have any kind of current flowing through it, therefore there's no voltage drop across any resistance in the circuit. So again, don't get fooled by this. Again, taking a look at this, I put my voltmeter right on that terminal that's bringing the voltage into the light bulb, and it is showing me battery voltage. But again, remember, there is no current flowing through this circuit. So, with no current flowing through the circuit, I have no voltage drop across this problematic connector of ours. Okay, so again, be very careful with that. Now, some people will look at open circuits, but rather than using a DVOM, they will use test lights. And it's a pretty good application of a test light. I've got 3 different test lights here. So I'll lay them up here so you can kind of see what's going on. One of the problems with using a test light is that it might not be the correct amperage for what you're trying to diagnose. If I use too large of a test light, okay, amperage-wise, I may cause damage to the circuit. Okay, let's say, for example, I'm looking at a circuit that pulls about 100 milliamps. Okay, well, if I get on there with a test light that is pulling 2 amps, then there's a good possibility I could damage that circuit. Okay, so ideally, I would have a test light that is going to be no more than the amperage of the circuit that I'm testing. Okay, ideally, it would be the exact same amperage of the circuit that I'm testing. Okay, this is not an ideal world, so I have to make do. So, how do you know what your test lights pull amperage-wise? Well, one thing I can do is just measure it right there at the car. I can do it at the vehicle. So, we'll do that. I'm going to set this up to measure DC amps in the big scale. Have to move my lead. We'll go back to amps. So what I'm going to do here is simply use the power supply of my circuit. All right, I'll put my test light on a known ground. All right, test light's going to be on a known ground. And what I'll do is I'll put the meter in series. Red lead, I'm just simply going to put on battery positive. Test light is on. Test light's on nice and bright. And as far as the amperage goes, I'm pulling 12 milliamps. That's 0.012 amps at about 12 volts. Okay, so that's pretty low for a test light. All right, we'll go ahead and measure the next one. Next test light. Do the same thing. I'm just going to put him into ground. My meter is in series between this and the positive. And I've got a nice bright light there. This one is pulling about 180 milliamps, 0.182, 0.183. Okay, so about 180 milliamps for this one. And I'll check my last one. Again, placing the meter in series. All right, I've got a nice bright light there, and notice this one is pulling about 3/4 of an amp, 0.747, 0.748, so pretty close to 3/4 of an amp at 12 volts. Okay, so what's that do for us? Well, gives us an idea of what circuits we can safely use our test lights on. Again, I'm going to set my meter back to volts so that I don't do something stupid and blow my meter or hurt a circuit. Okay, so let's take a look. One thing I can do with this test light, okay, again, if I get this light bulb not working at all, and again, some people like to check it, open circuit voltage there at the load, we know is not going to be very good. It's going to show me a full 12 volts, and that's not good for diagnosing, okay? So by using a test light, I'll put a load. Okay, so I'm going to use my test light. I'm going to start out with the highest amperage. As I mentioned earlier, I know that this light bulb pulls typically 2 amps, 2.5 amps, somewhere thereabouts, well, depending what filament I'm on. So let's check. Always check to make sure your test light is working, that your wires, the grounds, all of that is good. Okay, so my test light's working pretty nice right there. Okay, I can check it coming into there. I know I have a good bright test light. Okay, so I'm going to go across the terminal here. Do I have a bright bulb? I do not. Okay, now this is the 3/4 amps. So what this is telling me is that when I place it across here, that this circuit is not permitting even 3/4 of an amp to flow. Okay, so I know I've got a problem, all right? I've got my test light connected to a ground, so I know the ground side's not the issue. So now I'm gonna have to work my way back up the circuit. Okay, so I've got an issue. Okay, I know it's not there. I've got a problem there, but when I come there it is, nice and bright. So by using a test light of the appropriate amperage, I found that the problem happens to lie between this measurement and this measurement where I get a good bright test light. Okay, so that's a good thing right there. Now, let's test another test light. All right, so I'm going to place the clamp on a good ground. Let's check just to make sure that the bulb is working and my ground is in good shape. All right, so that's as bright as that bulb gets at 12 volts. All right, so it's good. Now, I'm going to go back in. Again, just like if the light bulb wasn't working, I'm one of the guys that tend to pull this thing out and check the voltage right here. Now look at this bulb. Notice this bulb lit. It's not as bright, but the bulb's still lit. Now notice there is a difference in intensity between this point and this point. So if I'm sharp enough to pick up the change in intensity, well, okay, then I'm going to find that there is a problem indeed there at our connector. However, just to show you, because this amperage is far less than the normal amperage of this light bulb, okay, the normal light bulb amperage here, this test light is glowing. And I remember this was about 180 milliamps, so when it was very bright, and it wasn't as bright as it should be, so I know I'm flowing somewhere less than 180 milliamps. But unless I was able to pick up the difference in intensity of this light bulb, I could have assumed that my power circuit was in good shape and that I was moving on to another side there. Okay. All right, so anyways, something I just wanted to show you, just to be careful. Now I'm going to show you the test light with the least amount of amperage. This test light is pulling only 12 milliamps. So we'll put the clamp here to ground. The test it to make sure that my test light is indeed working. Okay, it's nice and bright. That's beautiful. So let's go ahead and take a look and see what we have there. Look at that. Look how bright that bulb is. There is no difference, okay? No difference in intensity across, in this case, I know where the resistance is. Here's a case where this test lamp is pulling way too little amperage, okay? This circuit, with the unwanted resistance at this connector here, is allowing more than enough current to flow to light this bulb with its greatest intensity. So I am not going to see a problem using this particular test light because its amperage is too little. Okay, so again, with a test light, it's a very good idea to approximate the amperage of the circuit that you're testing. That way you've got an accurate load and you'll be able to come up with any type of unwanted resistance that way. All right, that's all I've got for this particular example. Hope this has helped. We're going to talk a little bit more about using a test light, the DVOM, and we're going to introduce a scope also just to show you what the patterns look like for an Aurora V6 type engine. All right, thanks for watching.